Right, good afternoon, everybody. Welcome to Form 4 Physics. As I told you before, we are going to be doing these little, not so interesting but necessary things to start off the Form 4 Physics. So tonight I'm just going to go over how we actually plot a proper graph in physics, and well, of course, I will also try to instruct you on a graph paper as well. So I'll try to keep this video short. So let's get started. So first of all, there are a number of rules as it relates to plotting a graph. And these are not hard and fast rules, but these are some of the things you must observe, or should observe rather, when we look at plotting a proper graph, a graph that will allow you, when you write, let's say that paper 2, which the first question is of course graphical work, right, that you can get that maximum amount of marks in the examination. Also, when you do your lab work, graph presentation is of course extremely important for you to be able to do proper analyses of your results. So a couple of rules as it relates to how we plot a graph. First of all, it's always good practice to use the entire graph page. So let's just say this was your graph page and this is the actual grid inside. You try to use the axis, the entire axis, right? So that's the first rule. Must use the entire graph page. Now, how do you plot these coordinates? Do you use dots as you do in mathematics? No. What we accept is a dot with a circle around it, as you can see here, or an X. Later on, I will show you just how big or how large you are allowed to draw that dot with that circle around it, or an X. Another very important thing is that the axes must be labeled. So, of course, we have two axes. The y-axis, which is the vertical axis. We don't really say y-axis in physics, we say the vertical, and the horizontal axis, right? So you label them. So if you notice in this little mock graph page that I have here, you always put the quantity that you're putting on this axis as well as the unit. All right? The next thing is that the graph must occupy 75% of the graph page. So if you take a look here, the graph that we plotted, right, takes up roughly about, approximately 75% of the graph page. You don't want to take a graph page and draw a very little graph there, because then it's very difficult to do accurate analysis on it, right? The other thing is that all graphs must have a scale placed on them. So you must always put the scale that you've used. X-axis, I just put that there, 1 unit to whatever. Y-axis, 1 unit to whatever scale you would have used. The other thing is the graph must always have a title. Now generally, let's say you're plotting rainfall versus day, right? Then the title of that graph is graph of rainfall versus day. That's all. So that's all you have to say. So if you're plotting distance versus time, the title of that graph will be graph of distance versus time. That's it, nothing fancy, right? And then, of course, how do we state a graph? So let's say I ask you to plot number of coronavirus cases versus the day of the month, right? Where will you put the number of coronavirus cases and the day? Will you put the days on the y-axis or the vertical axis, or will you put it on the x-axis? So what you really, if I say number of cases versus day, the first one, in this case, right, the number of coronavirus will go on the y-axis, whereas the days will go on the x-axis. So it's always in the form y versus x, the vertical versus the horizontal. So if I say plot a graph of A versus B, A is on the y and B is on the x. If I say plot a graph of apples versus oranges, apples will be on the y, and oranges will be on the x, right? And how they usually state it is that you may normally see it as A versus B, versus B, right? Basically, this is how you would see it, right? Or sometimes A against B, but that just means A is on the y, right? And B is on the x. Okay, so that's just simply how that's a jargon that is used. So if I tell you plot whatever versus one quantity versus another, the first quantity is the one that goes on the vertical or the y-axis. Right, so why do we plot graphs? Right, now let's look at the word graph, and it's short for graphic, right? So we are visual, and if there's a large number of a large amount of data, let's say numbers for example, for us to actually get a meaningful to get meaning out of those numbers, very often we plot them, and we can actually see maybe a trend as to how this particular thing that we're observing is behaving. So for example, let's look at this first graph here. This is what we call a linear graph or a straight line graph, and it's linear because, as you notice, all the points that were plotted seem to be scattered around a straight line, right? Now, this line, of course, is called a best fit line, right? Because if you notice, if I were to take off this line, it seems that all of these points are just scattered around a particular point around this line. So we drew a line that best fits the data. Now, what a best fit line is a line that passes through at least 2 points and evenly spreads between or passes between all the points of data that you got. Now, first of all, if you're noticing here, I have something called an outlier. So when you're plotting, when you're taking data in an experiment, sometimes one of your values will be affected by random error, and it will be a horribly off value. If you notice, all these values seem to be, along the line, and then one is way off, right? That is what we call an outlier, and we can disregard that. So this is the reason why we take quite a number of readings, so that if there are a couple that are off, right, we can disregard and look at the ones that best, seem to fit the line, or seems to give you that sort of function. So then if you look at this graph, for example, right, look at all the points. The points, they're not linear like this, but they seem to fit what we call a sine function. So I know you would have now only begun at maths and so on. So the sine wave is not very, very familiar to you, but this is actually an actual function, a trigonometric function that you will come across. And then, of course, this one here, there's no obvious trend. It's just a scatter of points. Of course, mathematicians may disagree with me and say, well, yeah, there is some sort of function that could fit that, but we're not here to discuss that, right? So basically, from these things, from the data that we have, we can actually observe the trends. So in this case, the trend is as the y values increase, the x values increase evenly as well, right? That's a linear function. The sine function, of course, well, that's something completely different, but it follows that sine trigonometric function. This sine curve here is a standard trigonometric curve. This, of course, I will go about and say that it really doesn't follow a pattern, it's just a bit of a scatter. All right? Now, not always do we draw best fit lines. So for example, let's say I'm plotting the distance traveled by a mosquito versus the time it takes, let's just use a mosquito, let's say a taxi, and the time it takes to go from, let's say, Pinal to Siparia, or to come back to its start point, for example. So it makes a round trip and comes back. So it would not make sense to draw a straight line, and that's because by doing that, you would say that the taxi is basically traveling at a constant speed. But this taxi wasn't doing that. It was traveling very fast here, it slowed down, it picked up some speed again, then it slowed down a little bit, and then it came to rest. So that's basically, well, not came to rest, but it was traveling a lot, but faster here, right? So basically, what we're looking at here is a graph where we actually have to connect the dots because we're observing some sort of phenomenon. Over here, right, this best fit line is that actual function, right, that fits the data as best as you can. So a couple things to remember again, these are the things that I required of you when you plot a graph. Must use the entire page. We use a dot with a circle or an X. Axes must be labeled and the unit that you're plotting must be there. The graph must pick up 75% of the page. The scale must be placed on the graph. The graph must always have a title, and generally it's in the form Y versus X. We still plot our regular, we coordinates as X and Y, but when I say it's always Y versus X, when we are telling you plot a particular graph and we give you two things, like let's say displacement versus time, right? Then displacement is on the Y, time is on the X. So what I want to show you now is how large the actual dot and circle will be. So if you look at my graph page here, and I'm going to zoom in just a little bit, right? Notice that the dot with the circle is no bigger than the smallest X, so the smallest block rather on your graph page. And also look at the X, it's no bigger than the smallest block, right? And that's important because when we plot a graph, we are doing some level of approximation. So what this says, if you look at, let's say, the dot with the circle around it, is that we're plotting this point as a dot, but this dot could probably be anywhere in that circle. Is that okay? Right. And similarly, if you look at this here, right, let me just kind of pattern right so it gets a little, right, you notice when the line touches that circle, although it doesn't pass through the point exactly, that's fine. We're saying that it is passing through the point. Okay? So this is just a little bit of the rules that we need to be able to plot a graph effectively. So what I want you to do for me is take a look at this and make a note, and then we will plot a graph so that you can practice and be able to effectively have all those little criteria that are required to plot a proper graph. So thank you, and I will see you again.